This video is about graphs of quadratic functions. So we're going to look at all of their key features, so the vocabulary words that are associated with graphs of quadratics. I do have this handout available on your D2L page if you would like a copy for yourself. I found that it is easier to do it this way so that you have the graphs that I have without drawing them. But you can just draw it if you would like. So here we have a quadratic function. Now I do think it's important to note that the parent function of the quadratic function starts at 0, 0. It's pointing upwards because it's a positive function. It's y equals x squared, or f of x equals x squared. And it should be even. My drawing is a little bit wobbly. We will get to that when we're graphing, so I'll do that a little bit later. But it's good to know what it's supposed to look like, and now we can see how it's changed. So there's a few things that you need to know. The vertex is the turning point of a quadratic function. In this case, we have a minimum point. If it is a negative quadratic function, like example 3 at the bottom, we'll have a maximum point. So this is the vertex. So this vertex is at 1, negative 4. The y-intercept you are used to. It's where the graph crosses the y-axis. So in this case, our y-intercept is 0, negative 3. There are two x-intercepts in this quadratic function. If you look at the original, it only has one x-intercept at 0, 0. But this one has two. You can have 1, 2, or none, and that's because of the power of the squared. So in this case, we have two x-intercepts, one at negative 1, 0, and the other one is at 3, 0. Notice that I'm writing these as points because that's what they are. They're points on the graph. The axis of symmetry cuts the graph in half. So you'll notice that the left side is congruent to the right side. This is always going to happen right in the middle with the vertex. So one thing you do need to remember that it's an equation. It's x equals, because a vertical line is an x equals equation, and it's always the x from the vertex. So x equals 1. So you can get that information from here or from the graph. Now I point that out because we're going to see some equations that are in vertex form, and we can take the vertex right out of it without graphing at all. The minimum value here, I'm looking for a y value. So I'm so sorry. I know that it's a minimum, not a maximum, and the value is whatever my smallest y is. So in this case, y equals negative 4. The domain of quadratic functions, unless they're restricted, is always all real numbers. Look at this arrows here. Not only are they going to continue to go up, but they are going to go out, and it's going to get wider as we continue on the graph. So the domain is always the same. It is all real numbers, or negative infinity to positive infinity. I would like the interval notation, please, and make sure that they both have parentheses instead of brackets because they're not an included point. Now the range is fun. If your graph is a positive x squared and the arrows are pointing up, you will always use the positive infinity because that's where we're going to. If your graph is pointing downward and you have a negative leading in the coefficient of x squared, you will always use negative infinity because our graph will be pointing or growing in the negative direction. So you'll have these two examples here. Wow, that's terrible. Well, I tried. Okay, so in our case, our arrows are pointing up towards the positive numbers, so we're going to have positive infinity. And then the lowest range value is your minimum value. So in this case, the lowest our graph goes is to -4. We will never use any number below -4. So we can say that our range is -4 to infinity, and it includes -4 because the vertex is a point on the graph. It is closed. Okay, so that's how you pull out all the information from a graph of a quadratic function. I have a couple more that we can look at. Okay, in this case, you'll see that my graph never crosses the x-axis, and that is okay. That just means I have no x-intercepts, so I'm going to put none in this space. The vertex is here. It is a minimum value of 1. The axis of symmetry, oh, sorry, I was writing vertex. I'm going crazy here. Vertex is 1, 3. Notice that that 1 is, I'm going really crazy here. My apologies. Looks like I need a nap, right? Okay, sorry, it's 3, 1. So that 1 is also used in the minimum value or the maximum value. That will always happen. Fun fact, it's also the range value. So that's the lowest point in the graph, that's the minimum, that's the vertex, that's the same number in the range. And because our arrows go towards positive infinity, we'll use positive infinity. Okay, I skipped over the y-intercept, so let's go back. Y-intercept is right here on the graph. It crosses at 0, 7. And the axis of symmetry, I drew it in. It has the same x value as the vertex, but you can also find it off the graph. And remember to put x equals 3. It's not just 3. You'll start getting really fast at this, and this is x equals 3 and y equals 1. Okay? This one is a line. Now, if you lose it off the y, that's okay. It's really a value, it's a point, but I need it on the axis of symmetry. It's an equation. Okay, last one. This time you'll see that we have a negative x squared. That's why we're pointing downwards. So I'm going to go ahead and write my range in here already. Ooh, I just noticed that I skipped domain for example 2, but that's because, we already know it's negative infinity to positive infinity. So before I skip it on number 3, I'm going to write that in, negative infinity to positive infinity. The vertex in this case is a maximum point at -1, 4. So I can go ahead and write my maximum is 4. My axis of symmetry is -1. And again, that's just these numbers repeated. They're just split up here. The y-intercept crosses the y-axis right here at 0, 3. And here we go. We got 2 x-intercepts this time. We have one at -3, 0. And we have one at 1, 0. Okay, quick and painless, right? Now, what happens if you don't have a graph and instead you only have the equation? So I'm going to show you how to do that in this section on the back. Okay, now the axis of symmetry, it really has an equation. X equals -b over 2a. And don't forget that equation. We will use it over and over and over again. So what you need to remember is, if you recall from the last video, I told you what it looks like in standard form to write a quadratic equation. ax squared plus bx plus c. So in this case, a is 1, b is 4, and c is 3. I'm going to plug those into my equation for the axis of symmetry. So -4 over 2 times 1 is -4 over 2, which is -2. So the axis of symmetry is x equals -2. To find the vertex, we're going to use this information and find f of -2. Because we know that f of -2 means an x value, and it's going to When we input that -2 into the equation, we'll get an output of the y value, and that's what we're looking for. So I'm going to plug in -2 to the original equation that's here at the top. Be very careful when using a negative and a squared. If you put it in your calculator incorrectly, it will do the math incorrectly. So just be aware of that. A -2 times a -2 is a +4. 4 times -2 is -8. Okay, and then when we add these together, what is that? 4 minus 8 is -4 plus 3 is -1. Okay, now we need to put the axis of symmetry and its y value together to get the vertex. So I'm going to use this 2 over here. Oops, it's negative. And this -1, and that is the vertex of our graph. Now, could I have graphed this and done that? Yes, but you can't use Desmos to graph these, so you have to graph it by hand. So what we really have to do is find all this information so that we can graph this. Okay, the y-intercept is actually one of the, I was going to say the easiest thing, but the easiest thing is the domain. We know what the domain is. The next easiest thing is the y-intercept. We're going to let x equal 0. Because if you remember, all of our y-intercepts from the other side were 0, something, right? 0, something, 0, something. That pattern always happens because x is 0 on the y-axis. Because I know that information, I can plug it into my equation and find out what my output's going to be, or my y-intercept in this case. So it's the same work that I did over here, but this time I'm going to plug in a 0 every time there's an x. And once you do this plenty of times, you'll see the pattern. This will happen most of the time. Notice that x and x squared are both 0, so we are left with 3. Okay, so we know that the y-intercept is 0, 3. Wow, okay. To find the zeros, we will solve the quadratic equation just like we did in the last video in the first part of this homework. So you can use whatever method that you would like. I'm noticing right now that this is factorable, so I can say, what are the numbers that multiply to 3? Well, that's 1 times 3, and 1 plus 3 is 4. So my factors are x plus 1, x plus 3 equals 0. But I got to keep going because I need the zeros, which are the solutions to this equation. And that gives me that x equals -1 and x equals -3. So I have 2 zeros at -1 and -3. And then finally, I need the range of the function. Now this is why I was trying to show you where I can get some information besides finding it on the graph. The range, the y value in the vertex is our range. So I'm going to use that information. And then I also need to check the original equation, looking at the coefficient of x squared, and I'm looking for a positive or a negative. Remember, positive means we're going to positive infinity, negative means we're going to negative infinity. In this case, we're going to positive infinity, so I'm going to write the infinity second, and then I need a -1 first, and it's included. It's always included, okay? So there you go. That's how you do the key features without a graph. Okay, I want to do another example in standard form, and then I have one in vertex form that we can use. Okay, axis of symmetry, x equals -b over 2a. A is -2, b is -8, and c is -3. So I'm going to take the opposite of -8, which is +8, divided by -2, which is -4. So my axis of symmetry is x equals -4. Now I'm going to use that information. I'm going to plug it back into my equation to get the output and see what my y value is going to be. Negative 4 times negative 4 is positive 16 times negative 2 is negative 32. 8 times 4, both negative, is positive 32, and then negative 3. That's lovely. I love that it did that. So now I know that this is equal to negative 3, and my vertex is, using the x from my axis of symmetry, negative 4, negative 3. Okay, now I can find my y-intercept, and if you notice the pattern, it'll always be the number at the end of the equation. So the constant that's by itself with no variables is the y-intercept, because this will always happen. So my y-intercept is negative 3. So we have a point at 0, negative 3 on the graph. I'm going to do domain and range really quickly because our zeros are going to take a minute. Domain, easiest thing on the page. Range, I need the y value from the vertex, negative 3. And then, before I keep going, I need to check the sign of my equation up here. It is a negative 2x. Now the 2, it's not going to do anything right now that I need to worry about. I just need to worry about the negative. Because it's a negative, I need to use negative infinity. And notice that when I use negative infinity, it goes before the vertex value. But it's still closed. Okay. Now, we need to find the zeros. So we can do a slip and slide, and that gives me x squared minus 8x plus 6. Let's check if we can find some factors that multiply to 6 and subtract to negative 8. If they're going to add to negative 8, that means they both need to be negative. So that would be 1 and 6, which makes 7, and 2 and 3, which makes 5. So this is a prime, so I'm not going to be able to do that. Instead, I need to use the quadratic formula. X equals negative b is positive 8 plus or minus the square root of 8 squared is 64 minus 4 times negative 2 times negative 3, 4ac, all over 2 times a, which is negative 2. Okay, so 8 plus or minus, what is 2 times 3 is 6, and that becomes a positive 6 times 4 is negative 24, so 64 minus 24 is 40. So we have 8 plus or minus the square root of 40 divided by negative 4. Okay, this looks gross. We're just going to leave it there. You could get a decimal for this to help you graph. We're just going to stop there. We say we found them, right? Now, you can reduce and simplify here. And if you do that, that's fine. Go right ahead, but we're going to stop. My video is getting a little long. Okay, very quickly, we're going to do vertex form. And sometimes people call it standard form, and then they call this one general form. It just depends on the book and the teacher. But vertex form has the vertex inside the equation. So it kind of looks like the transformation equation. Actually, it is the transformation equation, right? Where we just plug in the shift left and right and the shift up and down and then the change in the slope. But the axis of symmetry is literally right here, okay? You do have to change your sign. If you remember, I taught you by your x is lying to you, right? When you pull him out and he's lying. The vertex is both numbers, negative 2 and 4. We know the domain, negative infinity to infinity. We know the range. Now that we know the vertex and that we know that this is negative, so we know that it goes from negative infinity to 4. Okay, y-intercept, we're going to have to do a little work this time. We can't just say it's the last number because of this 2 inside the parentheses. So 3 plus 2 squared plus 4, That is negative 3 times 4 plus 4. That's negative 12 plus 4, which equals negative 8. So our y-intercept is 0, negative 8. And then for the zeros, we have to use the, square root method. So I'm going to write this equation again, but I'm going to move the 4 to the other side of the equation to give me a negative 4. So negative 3x plus 2 squared plus, I forgot what I told you I was going to do, equals negative 4. Divide by negative 3, so we have x plus 2 squared equals 4/3. I'm just going to leave the fraction. If you feel like changing it to 1.333, you can. Square root both sides. X plus 2 equals plus or minus the square root of 4 over the square root of 3. And then subtract 2 from both sides, giving me x equals negative 2 plus or minus. And I'm going to go ahead and do the square root of 4 here to give me 2 divided by the square root of 3. Now, I would love to say, stop, you're done. You cannot leave that square root of 3 in the denominator. I mean, you can. It's fine. It's just bad math. To get rid of it, or to move it, we multiply the denominator by square root of 3, multiply the numerator by square root of 3, and that gives us just the 3. So we have negative 2 plus or minus on the numerator 2 square roots of 3. And then we have gotten rid of our square root, so it's over 3. So there are your x-intercepts. And again, if you had to graph this, you would just do negative 2 plus 2 square roots of 3 over 3 in the calculator and get a decimal. Or you can approximate this value. Okay, good luck on your homework. I'll do another video for word problems and for graphing.